So welcome back, guys. Today I would like to also show you how we could implement our permission management setup in Rust. We already did something similar in the past, but we did that completely in Go. But now I would like to, of course, show you how we can do this in Rust. It's going to be pretty much similar, I guess, but I would also, of course, maybe take it a notch further and show you how we can actually even work with config files for a start. So we can, let's say, define some baseline for our permission definitions, and then of course maybe develop on that and decide how we would want to manage permission to resources, and even also of course denial of access to certain resources. So I will show you how we can do all of this in Rust. I've gone ahead to create a new, initialize a new project, and there's nothing much here. It's just like the regular main file, main function. So, but I'm going to go ahead and start making some implementations. I'm going to keep it as simple as possible. So I'll create a bunch of structs that's going to define a couple of things. I'll need one. I'll need one that will define permission. So let's define, maybe I'm going to leave everything in this main file, so I don't need to even add the visibility modifier here. So I define a struct called permission. So what I need to be in my permission will just be a path, which is going to be a string like we've been doing it before. And in here I would like to add some, of course I need to add some macros here. So I can say derive and add debug, and I'll need to add clone. I'm not sure. I need a partial equal. I need equal, and I need hash. I think that's all I need for now. Maybe what I can simply do is to go ahead and add an implementation, so I can do something like permission.new. So import permission, and in here I'm gonna just create a new function. Just it's just gonna take a path, which is gonna be a string, and it's simply gonna return self. And in here, what we simply do, of course, would be just to return permission, and then path would simply be path we can do to string like this, and that's all. Okay. Sorry. So now I'd like to also do the same for again, I don't think I need this visibility modifier. So I would like to define one for my roles. So again, it's gonna be pretty straightforward. So I need a name. So every role should have a name. This could be predefined, of course, can also be defined on the fly. So it's going to have a name, and it's going to have some permissions that's more or less defines this role. So I'll call this permissions, and this is going to be just strings, but I'm going to make this a hash set. So I would not repeat myself. So I can say hash sets, and of type, the data type would be of type string. And that's really it. And again, I'm gonna maybe do something similar here. I'm not sure I need all of this for my role. I'm gonna maybe keep it simpler for now. So let's just leave debug and clone. And now I implement my role. Again, I'm gonna do something quite similar like we did up there. So I need a new method. A new method is gonna take a name again, which is gonna be a string pointer, and it should return itself. So simply say role. So name, you have to do to come on name, seriously, name to string. And permissions, for permissions we simply say hash sets. It has its own new method, so we simply call the new method to initialize this, and that's all. And the next thing maybe I would want to do would be, because I want to be able to, of course, append permissions to rows, so I'd like to add a method called add permission. So it's going to of course have a mutable reference to self, and the permission itself that I want to add, which of course I'm also maybe going to use a string pointer. And of course, it's not going to return anything. So what it's still going to do for me is pretty straightforward. Say self.permissions. I can simply call the inserts function and pass the permission. And again, I say it's a string. And that's it. And why do we have some error? Okay, of course, I close this up. And that's it. Again, I'm going to keep it pretty straightforward because I want us to focus on what the important parts. So now I'm going to define my user, a user that's going to have all these permissions. So user, again, I'm going to paste the implementation I have for my role. So my user is going to be quite straightforward. So it's going to have an ID, which is going to be a string. Now it's going to have some attached rows. Again, in the spirit of what I've done above, I'm also going to make this a hash set. So I say hash set of type string. And it's also going to have so I want to be able to, aside from having some attached rows to this user, I also want to be able to attach like direct permissions, like what I have here. So I can, so the point for me is I would like to define a role, say admin, that has like default attached permissions to do certain things. But I also want to be able to say, oh, this user has just the permission to access this singular resource, something like that. And to do that, I would probably make it simpler and easy to read. I'm going to call it direct permissions. Again, it's going to be a hash set. And then I'm also going to add, I will also call this maybe denied permissions. So this is going to be a string. So the point for me would be I should be able to attach some direct permissions, and I should also be able to deny certain permissions. So, and this, of course, the way it should work, or the way it works normally, would be that these denials should take precedence over this attached permission. So what it means is that if you should give this user permission to access resource A, and then you also deny the accessibility of resource A, the denial will take precedence over the applied permission. That's really how it should, and how it normally works. So I implement user. I would like to add some few functions. So one would be the new method. I'm going to keep it simple. Again, string pointer. So mind you, this user can have other attributes here, like first name, whatever, doesn't really matter. So for now, I'm just going to keep it simple. And then for me, the important things would be these ones, to be honest. Okay, so and this new should now, of course, return self. And what I can simply do here is user. So ID would be ID to string. And again, of course, rows would be this. I did it already. Where is it? My hash sets this one. I'll just copy it because I don't want to type it again. So rows would be this. Direct, I want to do that in sequence, would be this. And denied, of course, would be this. And that's so we have our new method. And now, because of these additional attributes, I want to also be able to add rows and add direct permissions, and of course denied permissions. So again, let me start from rows. So I add a method called add rows. Again, it's going to take immutable reference to self, and a row which is going to be of a string pointer basically. And again, just like we did before, it's going to be self.rows.insert. And here I simply pass row to string like this. And of course I close this because nothing is being returned. And just like that, again, so I can say add, it's pretty straightforward. Add direct permission. Again, it's going to take immutable reference to self, and a permission, again, which is going to be a string pointer. I don't expect it to return anything, so So direct permissions, let's insert, simple as that. And now add my permission. To shrink, again, close this off because nothing is being returned. And I'm just gonna copy this because I don't want to waste time. So I'm just gonna modify this and denied permission. This will now be denied permission, and that's it. That's really all I want to do here. Okay, so now I'm gonna go ahead and implement the most interesting aspect, which will be our permission tree. So again, it's gonna be a struct. I'm omitting the visibility modifier, so it's not really necessary, but we'll see. So permission tree. It's going to have one simple attribute. I'm going to call this root, and this is going to be my tree node. Again, I'm going to, of course, maybe add clone and debug. Let me see. Okay, just we'll figure that out along the way. And now I'll implement my tree node. So again, it's just going to be like we did before. It's going to be pretty straightforward. So it's going to have children. This children is going to be, I'm going to use hash map, string and tree node. So that way I can more or less recursively access itself again. So we still have our method called wildcard, which should be a boolean that tells us, of course, if we are more or less if we've gotten to let's say a landing more or less within the permission tree. So again, I need one called is endpoint again, which is going to be a boolean basically. And that's it. Again, I'm going to copy these implementations, come over here and dump them. Pretty straightforward. And now what I want to do would be to import tree node. Again, I'm just need a new method. We should, of course, return, should take nothing and return itself. And then here we simply call our tree node. So children is going to be simple hashmap.new. So hashmap.new is wildcards, of course, will be false for now, and this, of course, will be false. Okay, that's our tree node. And now what I would like to do would be to implement this guy. So import PermissionTrie, and this is where we more or less bring it all together. So I need a new method that's going to give me a new instance of PermissionTrie. Again, it's going to be pretty straightforward. So PermissionTrie, and in here it should just be tree node, and we call the new method we just created, and that's it. Okay, and now I need an insert method. We should be able to take, of course, we would modify it, so it should take a mutable reference to self and the permission, which should for now be a string because that's how we are handling our permissions. Pretty straightforward. And now what I want to do is to define a node, which would be a mutable copy of our root. Okay, and now what I simply need to do is to more or less process the parts of this permission to more or less decide what to do. Is it a wildcard? Is it an endpoint and stuff like that? So I need to define an argument called parts. So basically I take this permission and I trim matches, this one, and of course I provide my argument. It should be a I should actually do it like this. So it should be a forward slash, I guess. Is it back? I think it's a forward slash. So I call the split method. Come on. I call that, press that multiple of times. And then I split, and then of course I collect this into a vector. And now I need to more or less define what I'm getting back here. So this should be a vector of string pointers basically. So something like this. And now what I can simply do is loop through my parts. Maybe I, indent this. So I'll say for parts, in parts. And what I can simply do is to check if it's wildcard. So I can say if parts is equal to a wildcard. So if we've hit a wildcard, no, now we update this. So is wildcard would of course be true. And now simply break. We'll break out of the loop. But if that's not the case, now what I can simply do is to update my node. I can say node.children. I can call the entry method, and I provide this part. I need to convert this to a string. And what I can do is to, if this already is there, I will access this as a current node. Otherwise, I use the or inserts method to create a new node at that point in the tree, basically. So I can simply say tree node dot new. If we do not have a current node at this point already. So if we do, we access that node as our current node, and if not, we create a new one. It's really that straightforward. And now in the end, of course, I notify that this is the end node, basically. Okay, so we have a new permission. If it's a wildcard, we'll note this, of course, we'll break out of our for loop, and then we, of course, notify our node like this. But if that's not the case, of course, as also what you've seen here, we simply create a new node at that point. That's really it. And why does this? Okay, now I've saved it, should update for this. Okay, so I would also like to create a few more. Maybe I'll just create one more function that's going to help me to determine if permission actually exists. So I'm going to call this has permission. I think like we did already in the past. So I probably don't need to modify this since I simply need to check. So this should return a Boolean, and we don't need to modify the permission tree itself. Okay, so I'm going to do exactly what I did up here. So I'm going to say let parts equal to this. This would of course come from, now I change this to path. So we'll basically of course split the permission we have to more or less get the current, get the paths. And now I also need my node, which is also going to be something similar. So I'm going to simply type this out. So I say node, maybe I make this mutable. So let mutable node self root. Again, I'm going to do something similar. So for parts and parts, again, I would say this is quite similar. So I would say if node, sorry, I want to check for wildcard. So if it is a wildcard at this point, I simply return true. It means it has a permission at this level. Okay. Otherwise, what I can simply do is I use the if-let syntax to check for the next node. I'm just going to call it next node. And this is going to come from, of course, node.children. And I try to get the current using the path. So if this is the case, again, what I would do, of course, now would be node would become our next node. But if this is not the case, what I can simply do again is just to return false. So it's either you match at this level or we keep traversing the node tree, basically. So if we do not have a wildcard and we can no longer traverse our node tree, then of course that's it, that's the end. You don't have any permission. Okay, and then in the end, when we are able to, of course, get what we want, what we can now simply do is we check if this is the endpoint, or what we can also do, of course, would be if it's a wildcard. And that's really all we have to do here. Okay, so I would like to implement a helper function, and for that I'm going to create a new struct, and I'm going to call this RBAC. Yep. And here is going to again be similar. It's just going to help me to manage the whole thing. So I need rows. So roles would be again a hash map of string and role. So I need my users. Again, you don't need to do it this way because you would have this stored somewhere. So, but everything we are doing here would be in memory managed. So that's also why I need to do it like this. So I need permission tree. Again, this would be of type permission tree, as simple as this. And now I need to implement my RBAC because I need a couple of helper functions. So I need new. So new again, just like we've seen before. Simply return RBAC on rows. Again, pretty straightforward. Hash map dot new users hash map dot new. That's why those helper functions are quite handy. And permission tree would come from permission tree dot new. Again, that's pretty straightforward. And apart from the um, new method, again, I will need to implement some interesting functions here actually. So the first one would be again pretty straightforward. So I need one that's going to help me to add role. I need a mutable reference to self because I'm going to modify it, and role is going to be of type role. And again, self.rows.insert, and I simply add so row, I'm going to use the row name basically dot name. I'm going to clone it, and then for the value I'm simply just going to pass row and close it up because I'm not returning anything. So I need another one for add user. It's also going to be quite similar. So again, you need a mutable reference to self, and you need a user of type user. And again, self.users.insert. For the key, again, I'm going to use user.id. I'm going to clone it as well. And for the value, I'm just pass the user. And that's really it. So now the interesting thing, of course, would be I need a method that's going to help me assess if a user has permissions. So I'm going to create a method, and I'm going to call this something like I don't know, check maybe item resource access, something like this. Resource access. Again, I will not need to modify anything, so I simply take self. I need a user ID, which is going to be of a string pointer, and then I will need a resource scope, because again, remember, for our setup to work, we need that every resource in our ecosystem should have a scope. So the scope is basically what's going to help us to manage and assess who has permission to what. Okay, so I'm going to use the if let syntax. So again, we'll first access the user. So will be user. We'll go to our users and we'll try to access by the user ID. Okay. So if we are able to have access to this user, now what I can simply do is to check if this user, because again, we said that we want our denials to take precedence. So the first thing I'm going to do more or less to check if the user has a denied permission to this scope. So I can say user that's denied permissions that contains, and I pass my resource scope. So if that's the case, I'm gonna go ahead and simply return false, and that's it. Okay, so that's the first guard that's we are gonna put in place. And don't mind the error, of course. Our whole setup needs to have an else block, but let's keep it straightforward for now. We'll come back to this later. Sorry. So now what I need to check is if the user has a direct permission for this scope. So I check the direct permissions that contains, again, resource scope. If that's the case, I want to return true. because I don't need to proceed any further. Okay, so but if that's not the case, that means I have to traverse the role that the user has, and of course also the permissions. So now I need to loop through the roles. So I can call this let's look at the names. So I'm going to call this role name in user dot roles. So we'll check the roles that this user has, and again we'll try to access those roles. So I can again use the if let syntax. So if let, again I'll call it role because that's exactly what it is, and I loop through our rows and try to get this one. So again we use accessing it by key, in this case role name. Okay, so we get our role at this point, and again we'll check if permission actually matters or applies. So I can now say if role.permissions.contains, and again I provide my resource scope. If that's the case, again I would like to return true because it means we found what we're looking for. But if that's not the case, now I would like to check permissions. So now I can say for permission in, again it's role.permissions to check the permissions within this role. And now what I can simply do is maybe do some string manipulation. So I can say if this ends with, so if this is a wildcard, for example, but this is not enough to more or less ascertain if this is applicable to this user, because again I would like to also pay attention to, like, more or less be quite careful here, so I don't just look at the end, but of course I'm also going to consider the scope, the resource scope itself. So I can say resource scope dot starts, and now I need to trim my permission. So I can say permission dot, I can say trim and matches, and again I provide my wildcard. So if this is the case, again I'm going to return true. It means I actually found what I'm looking for. Okay, so but if that's not the case, then what I can simply do at this point would be I'm going to just use my has permission function. So I can say self.permissionTree dot has permission, and I simply provide my resource scope, and that's really it. So otherwise, if that doesn't work still, then at this point what I can simply do is to return false, and that's really it. So it's really pretty straightforward like this. And what we can now simply do, of course, to test all of this is to now come to our main function and bring it all together. Okay, so the first thing I'm going to initialize would be my RBAC. So again, we have our handy function, this new function. Okay, and now I'm going to define some rows. So I'm going to define some rows. So I'm going to define one called maybe admin. I explicitly name it to say admin role. So admin role would be say role. Again, this is also why we have a lot of handy helper functions. So we'll call it admin. And now what I can simply do is admin role. I'm going to add a bunch of permissions. So I'm going to do something like org, maybe org1, and I say I give it permission to everything in org1, something like this. And maybe what I can also do is to admin role dot add permission. I can also give it permission to everything maybe in org2, and now I can go to, I don't know, Europe, and go to Germany, and go to maybe Berlin, and I'm going to stop here. I say device one. I'm going to give it permission to a certain device. So this is going to be my my admin role. So now I can maybe go ahead and define a new role. And maybe to keep it simple, I'm probably just going to copy all of this and dump that in here. And now I rename this to user role, something like this. So this would be my user role. And again, I'm going to make this one maybe more specific. So I can say org1, maybe Europe. And in this case, I'm going to, oh, sorry, my bad, user. And this one, I can make it also maybe leave it as org1, but now I can say Europe to say, so this person has permission to only everything within this organization. Maybe I'm going to make everything org1, so it's a lot easier to track. And in this case, I'm going to maybe make this device 2. But I want everything to all be within the same organization. So as again, I should not forget to update this part. So I'm updating the roles that this user has. So now with these roles defined, I can simply add this to my RBAC. So I can say RBAC.add role, and I simply add my admin role, and I do the same again, RBAC.add role, and I can add my user role, and that's pretty straightforward. Okay, so now I can go ahead and define, come on, users. So again, I create a mutable or user1, and then I say user. I use my handy function again, and I'm going to give this some really simple ID. So this would be user1. Okay, and now I would like to add some direct permissions or some roles more or less to this permission. So I can say user1 dot add role. Did we call this roles? I think this is wrong. Actually, it should be role because it's just one role. Okay, so this would be add one role. And now, of course, I give it a name. We give it a name of admin as the name of the role we created. And it has one attached role. What I can also do is add some direct and deny permissions. So I can say user1 dot add direct permission. Maybe I first add a direct permission. So again, it's going to go to org1, and I can go to Europe, Germany, and org1 Europe, Germany, and okay, I also maybe give it permission for device 2. For example, let me see. Maybe I just call this some random device 3. And again, I copy this part actually, and now add a direct denied permission, and I'm going to maybe make this device 1. So this should be interesting. So I'll deny it permission from with of this device 1. But again, remember this admin role has permission to see everything within this organization. Okay, so that's also one good way for us to actually test if this thing is behaving the way we would expect it to, more or less. Okay, so we have our first user. Maybe I can also define a second user to make it a little bit interesting. Like say user.new. Again, the ID would be user2. That's a very great idea, I guess. So user2, and now I add role, and I'm going to give it the user role we defined. Again, in your own case, these permissions might already be predefined or of course defined on the fly. And again, they don't need to be in memory, but I'm just doing that just for test cases. So I'm going to give it permissions for org1, Europe, Germany, and then device 1. Yes, so I'm denying its permission for device 1. So when all of this is defined, I'm going to add them to my RBAC. So I can say RBAC.add user, I add my user 1. Again, RBAC.add user, come on, add user 2. So I have my users created, my rows, everything created. So now I need to define some dummy resources. Okay, so I can say let's resources. This is just going to be a vector basically. It's just going to be a vector with a list of IDs. That's really it. Sorry. So I'm going to just copy this one to make it simpler. I'm just duplicate this. 1, 2, and 3. And of course, I change the ID. So this becomes 3, this becomes 2. So now we have our resources. So now what we can simply do, of course, is now to check who has permission for what. Simple as that. So I can say for resource in resources. So we loop through our resources, and what I can simply do is maybe I just print this so we can actually see, and I can say like user 1 has access, for example, and in here I'm just gonna call our RBAC.check resource access. Again, this would be for, come on, what happened? So this would be for user 1, and the resource of course would now be resource. And then we also do the same for the second guy. So this will not be user, so I say of course user 1, and then this would be user 2. And now we can just run this and see what we get, and then of course we can analyze the results together and see. So I can simply say cargo run, and let's quickly see. So now we see user 1 has access false, 2 false. So user 1 had the admin admin role attached, and of course the admin role had permission to see everything. Specifically, the device 1 permission was attached directly. Okay, but now here it says false also because we also have like a direct deny permission attached to it. So if I should, for example, comment this part out for user 1, it should now show us that it has permission. So now it becomes true, but it's a false because we actually had a direct deny permission attached. So again, I'm going to leave this for you so you can also go ahead and check things out on your own to see if things are actually the way you would expect them to. So but this more or less was really what I wanted to show you. The next thing I could also show you is to maybe, instead of having all of this defined this way initially, we can maybe start off with like a config YAML where we'll give the user or or more or less we have the permission or this process to actually predefine some base unique permissions, like let's say a super admin role, an admin role, so we don't have to do all of this, let's say each time we initialize our app. We can simply read the config file and have all this in hand. So to do that, I would of course need to install a package. So we're going to do that as quickly as possible now. So I can quickly come to our dependencies. As you can see, we really have nothing here. So but I need to add seri YAML, and I'm going to use version 0.9. So we'll give that a couple of seconds or maybe minutes to install, and then we can proceed. In the meantime, I've also prepared what my YAML file could look like. So I can create a file called config.yaml, and I just paste that in here. So again, it's pretty straightforward. So I have in here is the root defined default roles. So I've given it a name and some permissions. So it's going to have some allow and some deny. So in the allow, is going to be some read and write list of permissions. If you look here, for example, for this, I've defined like 3 permissions or more or less 4. So I have super admin has permission to read everything. There are no denies, so he can do almost everything. So again, we have a regular admin that's maybe has permission limited to like say root. Let's assume there's some root org, more or less. Again, this is just generic, and define whatever it is you would want to define here. Okay, so that's it. And then for the developer, I also have something similar, and then I have this one called reader. So, but the interesting thing is that you have the option of adding allows and denies. And for each of the allows and denies, you can now specify a list of reads and writes. So because I'm grouping, in the end, it's all about data access, right? So, and in the end, of course, this data has to be persisted somehow, because in the end, again, I will have to translate this into queries, because more, all this does not really make sense if we don't somehow have to connect this to an actual database, basically. So, but the points here pretty straightforward is that you have the permission to deny a list of reads permissions and a list of write permissions for all the users. Some base users you can define, okay? And now what I can simply do, of course, is to again copy this here and go to the web browser. So I'm going to bring this here. I hope you can see my screen. And now I can simply type YAML to JSON and maybe use this first one here. I simply paste my YAML and I get back my JSON. So I copy everything. And now I can again come up here and type JSON to struct Rust. And then you will see this nice tool called transform tools. You can simply come in here and I can simply just paste the JSON here and we get a nice struct out of our JSON. So I'm going to copy this and come back to our project, and maybe in our main file, for example, and maybe before our main file, I can just dump all of this in here. So, but that also means, of course, because of this, I need to install cd. So I'm going to take all of this out and come up here. So we're going to get a lot of errors, but that's also fine. So come here and paste this. But I think that's also wrongly written. So anyways, first of all, I'm going to come to our cargo toml in here. And now I need to just add cd. So in here, I provide my version. So sorry, version should be like this. So version is going to be 1.0, and features. I'm going to add, come on, derive. And now I can come in here, of course, and modify this import. So I can just get rid of this and now say use cd and deserialize and serialize. Okay. And that should take care of our imports. And now what I can also simply do is to come down to the bottom and then maybe actually modify some of the structs, the one that I just imported basically right now from that online tool. So I can come to that imported JSON here, this one named roots, and I can rename this to say app config. Okay, and now what I can also do is to now come to the bottom down here and implement my app config. So app config. Again, I'm going to add, as you can already imagine, my new method. So, but now I would like to provide a file path, which is going to be again a string pointer. And in the end, it should return for us. Maybe I make this optional, app config. So what I would like to do is to, in the initialization, to pass a path to a config file, and then we can read it and parse it basically. So I can say config, I can call this content. Maybe I use my match to handle any possible error. So I need fs, and I can say read to string, and I pass my file path. And because I'm using match, I have to handle all possible scenarios. So when everything goes well, I should have my contents and I can simply return this. But when I have an error, Any form of error doesn't really matter. I'm just gonna return immediately. So I'm gonna return none. Okay. So now what I can do at this point, I have my config, and this config again is gonna come from, I'm gonna use the tool we installed before, which is this set YAML. And I called it from string method, which is this one, and I pass my config content. Again, I can also match this. I can also match this so that if everything goes well, again, I have my config, which I can simply return. And so again, maybe I actually type this. So this should be of type app config. So again, if we have an error, I don't care what error, I simply return again, none. Okay, but now if everything goes well, I simply return my config. Okay, so at this point we have our config, and now what I can simply do is to maybe at the bottom here, I can simply say maybe config equal to common app config new, and I simply pass the path, and it's going to be config.yaml, as simple as this. And now I simply print this again. Like I said, the config, I simply dump my config dot maybe I simply call unwrap, doesn't really matter, I don't want to handle the option. Maybe I also do something like this, so we can have this. So now I can run this one more time to see what we get. Give that a couple of seconds, minutes. And now you can also already see we are able to pass our config. So this is one cool way, more or less, you can, of course, take care of this so that we don't have to do all these definitions from, like this. And we can simply, depending on what we have in here in the config YAML, we can read this and parse this, assign this to some initial, some root list, some default list of defined roles and permissions and stuff like that. And then we can, of course, maybe add on top of it. So our users can define some custom rules that we can, of course, add on top of those. Anyway, guys, that's all I wanted to show you in this series. It was, I would say, a quite short one, but it's still quite informative because, again, as you can already imagine, there's a lot more we can do if we expand from this point onwards. Anyway, guys, that will be all for now. And yeah, if you have questions, please feel free, reach out. I would like to hear what you have to say. Your feedback's actually quite interesting to me. So if you have any, don't shy away from letting me know what you think. If you have suggestions and stuff like that, again, also feel free to reach out to me. That will be all, guys, for now. And yeah, until we see each other again, have a lovely evening. Stay learning, and bye bye.